Over the course of my life, I've encountered discoveries and ideas that changed how I understand the universe around us. I'd like to share that journey with you. Come walk with me. In the last 3 episodes, we've examined an impressive collection of evidence supporting Alfred Wegener's continental drift hypothesis. The continents fit together, fossils matched across oceans, mountain ranges lined up, and ancient glaciers once covered what is now the southern hemisphere. Then came another remarkable discovery. Geologists found coal in Antarctica. Coal forms from lush forests growing in warm, humid climates, not beneath miles of ice at the South Pole. With so much evidence pointing in the same direction, why did most geologists reject Wegener's continental drift hypothesis? Let's find out. Welcome to Antarctica. No, this isn't a mistake. This is Antarctica as it may have appeared more than 250 million years ago, long before it drifted to the South Pole. Instead of an endless sheet of ice, Antarctica was home to lush forests, broad rivers, and extensive swamps. It was a warm, humid world that produced enormous amounts of plant material. That ancient vegetation would eventually become one of the most compelling pieces of evidence supporting Alfred Wegener's hypothesis of continental drift. To understand why coal in Antarctica was such an important piece of evidence, let's first see how coal is formed. It all begins in warm, waterlogged swamps like this one. When plants died, they fell into the water where oxygen was scarce. Because decomposition was so slow, layer after layer of dead vegetation accumulated on the swamp floor. Over thousands of years, this organic material gradually formed a thick layer of peat. Over time, layers of sediment buried the peat. As it was carried deeper into the earth, heat and pressure slowly began transforming it into coal. Over millions of years, increasing heat and pressure transformed the buried peat into coal. What began as the remains of an ancient swamp had become a coal seam. Everything you've just seen leads to this. This is not a scientific reconstruction. It is a photograph of geologists recovering coal in Antarctica. The coal was found in the central Horlick Mountains, approximately 350 miles from the South Pole. Think about that for a moment. Coal forms in warm, waterlogged swamps filled with abundant vegetation. It does not form beneath kilometers of ice. Finding coal this close to the South Pole became one of the strongest pieces of evidence supporting Wegener's hypothesis of continental drift. Alfred Wegener first proposed continental drift in 1912. Over the next several decades, the evidence continued to accumulate. Fossils, matching mountain belts, glacial deposits, and eventually even coal recovered from Antarctica all pointed to the same conclusion. Yet for nearly half a century, most geologists remained unconvinced. Not because the evidence was weak, but because Wegener could not explain how continents could move. Without a convincing physical mechanism, many scientists simply could not accept his hypothesis. In our next episode, we'll see how that missing piece was finally discovered, and how it transformed one of the most controversial ideas in geology into the modern theory of plate tectonics. If you're still with me, thank you. This is exactly why I call this series Come Walk With Me. We're not just following the history of continental drift, we're walking beside the scientists who struggled to understand it. Sometimes the evidence is already in front of us. The difficult part is recognizing what it means. Thank you for walking with me.